So generally I do the examples in the textbook in these videos, but every once in a while, if I think it will be helpful to you, I'm going to include a bonus problem. So I just title it that way because it's not one of the exact examples. I usually get these out of the Now You Try It. So if you want to try this example on your own first and then watch the video to see if you get it right, that's a good idea. Okay. So this function's a little bit different. You'll notice that you have a square root involved. So we know x has to be greater than or equal to 0 because we can't take the square root of a negative number. But it's also in the denominator, and so x can't be 0, right? So up here with the square root, we want to say the square root of x. That means x has to be greater than or equal to 0. But because it's down in the denominator, we have to say, well, x cannot be 0, okay, because then that would be dividing by 0, right? So we have both restrictions here. So what is the domain? The domain would be then, it's going to be x is greater than 0, no equal to, and so it would look like this, 0, parentheses, 0 to infinity, parenthesis. Okay, so that was kind of the bonus problem. Now I'm going to use that to explain the different notations. So if I want to show a graph of that set from 0 to infinity, here's 0, I would put a parenthesis at 0, or you could use the open dot. I think your textbook is going to use the parenthesis, but they might use, maybe they do use an open and closed dot. You'll see both. It just depends on the textbook what they want to show you. So parenthesis or an open dot. By an open dot, I'll show you underneath. When we use an open dot, we just put like an open dot like that. Sometimes those are hard to draw, but so are the parentheses. Anyway, our domain is going off to the right, so in this case it would look like that. And I don't care if you use the parenthesis or the open dot, you're going to see both. So, okay, that's the graph, what it looks like. What does the inequality notation look like? Well, we did that already. We said x is greater than 0. That's the inequality notation. Set builder notation. We haven't talked much about set builder notation, but set builder notation comes like this. It's the set of, and in this case, x, because that's our domain. That's what we're representing with our domain. And then we draw a line. That line means such that. So we're saying there's some x, some set of x, you know, these elements, and then here's the condition. And then usually we just put whatever the condition is that we have. So we're saying it's a set of x such that x is greater than 0. And that's how we describe the set. It's called set builder notation, and you'll see it. There's more examples in the textbook as well. Set builder notation is another type of notation that is used. Sometimes it's helpful to use set builder notation. A lot of times it's easier just to use the interval notation. You'll see, I think, a lot more of the interval notation, but they give you some examples where you can practice both. So in interval notation, it's going to be parentheses 0 to, 0 to infinity, parenthesis. And so that would be the interval notation. Okay? So those are examples of graphing, inequality notation, set builder notation, and then the interval notation. I just want to mention one thing. When we talked about all real numbers, and we could describe that, how would you graph all real numbers? Well, it'd be a graph, you know, a number line, and then you'd have to say it's everything. So that would be, you'd have to put arrows on it, but that would be a graph of all real numbers. How would you do it as in words? You'd say all real numbers. And that sometimes they'll put that. Textbooks will do that. The notation they give in set builder notation, there's a symbol for real numbers, and it's a fancy R. I call it a fancy R. Probably looks a little bit different in the textbook, but that's the set of, that represents the set of real numbers. I wouldn't get too worried about using that because sometimes it gets tricky when they use different notations for sets of numbers, but that's the standard way to represent the set of real numbers. And then from interval notation, we talked about that. It's going to be from negative infinity to infinity, and that represents all real numbers. Okay?